Yeah. So I screen share pandren. Just let me know if you guys are able to see it. Oh, things are now ready. Yes. Is it visible to all of you? I hope you're able to see it. Right? Is it displaying the blackboard? And the topic also is written. Yes. Sundareshan, you're able to see it?
Yes, sir.
Yes. Okay. Fine. Yeah. So this is a chapter that I've planned for today. So system of particles and rotational motion. So we have looked at the animation part. Quickly, we will brush through all the important concepts, the definitions and formula. In short, we call this as CDF. So we will look at the CDF module and then we will proceed. So I'll give you the important aspects of all the formulas, comparative formulas. We'll start solving the questions. Okay, then we are good to do all the questions. Fine. So here we'll go. The basic concepts வந்து நம்ம எல்லாம் cover பண்ணிடலாம். So first is center of mass. So can anybody tell me what is center of mass in your own words rather than the textbook definition? What do you mean by center of mass? Yes, the floor is yours. Anybody can volunteer. You can tell me in your own words what is meaning of center of mass according to
Sir,
you.
the point
All the
Yes.
masses lie at the same point, sir.
All the masses lie at the same point. Okay. Okay. Anybody else? You were trying to say something. Yes. Okay. Anybody else? Sundareshan was trying to tell, no? Somebody else also was trying to tell. Yeah.
Sir, the point where the entire mass of a body is concentrated.
Correct. Center of mass is actually a point where the mass of the entire body is being concentrated at that point. And the point and the body or the entire mass may concentrate at that point, everything is getting concentrated. So therefore you call that point as the center of mass of that particular object. So in simple terms, we can define center of mass as the point where the entire mass of a system is said to be concentrated. So I'll just make a note here. It is a point where the entire mass, where the entire mass of a system is said to be concentrated. So on the point we call it as center of mass. So such a point we define in simple terms as center of mass. I hope this part is find out the center of mass of certain particles.
Okay. First question,
now when I take many number of particles, if I'm going to take by using a simple relation. Okay, so I'll just give you a basic. Let us assume n particles. N particles நம்ம வந்து assume பண்ணிக்கலாம். So we are assuming n particles. Okay, I'll mention it here. N particles having masses.
மூலக்கூறு எடை எவ்வளவு வரும் 80 கிராம். ஆனா இப்ப கொடுத்திருக்கிறது வந்து 0.08 கிராம் கொடுத்திருக்காங்க. அப்ப என்ன ஆன்சர் வரும்? எந்த ஆன்சர் வரும்?
So n particles are there having, so we will assume that they are having some position vectors அப்படினா with position vector 2 Rn bar.
The E is, yeah,
Okay.
6.22
Then
over 20 is
the center of mass
புரியுதுங்களா?
of these
Question
particles
2. யாரோ ஒருத்தர் படிங்க question 2.
is given by, so upper, then we can generalize the center of mass as it's given by RCM, okay, is equal to M1 R1 bar plus M2 R2 bar. So it's product of mass times its position vector, okay, from the point of origin, plus so on so forth, plus Mn Rn bar upon sum of the entire masses, which is M1 plus M2, so on up to Mn. So this is the general formula for center of mass. So product of mass and the distance from the point of origin, at which distance that mass is located. So this is the basic formula divided by the mass, entire mass of the system of particles. ஸோ நம்ம இப்போ இதை ஜெனரலைஸ் பண்ணலாம் யூசிங் சிக்மா. சிக்மானா நம்ம சமேஷன் ஆப்ரேட்டர் யூஸ் பண்றோம். ஸோ யூசிங் சமேஷன் ஆப்ரேட்டர் we can write sigma I is equal to 1 to n mi ri, okay, ri bar, that's your position vector, upon sigma mi, which is a total mass. சரிங்களா? I is equal to again 1 to n. So in the mari you can specify. Is it clear? So this is the relation, this is the formula for center of mass for n particle system. Generally we can write using this relation. You can directly find out the center of mass of n particles distributed in three-dimensional space using this relation. Now when I say three-dimensional space, now we can find out the coordinates of the center of mass. When you take three-dimensional space, what are the three axes we have? We have x, we have y, and we have z axis. So when you have particles which are distributed along these three axes, then we can find out what is the center of mass with respect to x coordinate, with respect to y coordinate, and with respect to z coordinate. So all the three coordinates we can find out the center of mass. Okay, so we will now just go a step further and we will write down what is the center of mass for a three-dimensional Cartesian coordinate system. So now we are going to see the center of mass for the coordinates are given by same இதே லாஜிக் தான் நம்ம அப்ளை பண்ணுவோம். ஸோ எக்ஸ் சென்டர் ஆஃப் மாஸ் அப்படின்னு சொல்லும்போது எல்லாமே இன் டர்ம்ஸ் ஆஃப் எக்ஸ் கோஆர்டினேட் நம்ம ரெப்ரசென்ட் பண்ணுவோம். ஃபார் எக்ஸாம்பிள் எக்ஸ் சென்டர் ஆஃப் மாஸ் வந்து நான் எக்ஸ்சிஎம்னு போட்டுக்கிறேன், கேபிட்டல் எக்ஸ் ஐ எம் யூசிங் நோட்டேஷன். ஸோ வி வில் ரைட் திஸ் as m1 x1 plus m2 x2 இந்த மாதிரி போகும், plus so on until mn xn divided by summation of all the masses m1 plus m2 so on up to mn. சரிங்களா? முடிஞ்சது. So this is for xcm. So in simple terms can be written using summation operator. So I will directly write sigma mi xi upon sigma mi இப்படி எழுதிக்கலாம் for xcm. சரிங்களா? So same way for y center of mass also we will write down. So how can we write y coordinate center of mass using the same relation? How can we represent using summation operator? Anybody? Again, instead of x you would represent y, isn't it? So sigma mi, in the time yi would come upon sigma mi. Same way for z, center of mass is represented as summation sigma mi zi upon sigma mi, sum of all the masses. Now these are the formulas for the coordinates of center of mass, okay, for x, y, and z axis. Okay, so this is how we find out. சரிங்களா? I hope this part is clear. Any doubts in this? Okay, so these are the basic ideas and the formulas we have seen. We have applied the formulas also. We have found out what are the formulas for x, y, and z coordinate. Now based on this there can be different questions which can be coming up for the competitive exam. So இப்போ நம்ம இந்த கான்செப்ட் சென்டர் ஆஃப் மாஸ் அப்படிங்கிற கான்செப்ட் we have seen for n for a particle. So நம்ம அதுதான் பார்த்திருக்கோம். Okay, so this is the center of mass for a particle system, n particles, m1, m2, n3, so on up to mn, which are distributed in the dimensional of these system of particles. So that is what we have seen so far. Okay, same way we can also, if the now the we are assuming that these particles now are at rest. Not necessarily all the particles have to be at rest. Suppose they're in motion. They are static, well and good, you can apply this and you can. What if they are dynamic? What if there is the next level that we are going to see? Okay, so next we are going to see what is the velocity of center of mass. Let me just see the number. Okay, so number 3. Fine. So I just put the number 3. Yeah. Third number. So now we are going to see the velocity of center of mass. Okay, so velocity of center of mass அப்படின்னு சொல்லும்போது when the particles are moving with certain initial velocities. Okay, so in that case we can represent the velocity of center of mass as VCM. So generally VCM அப்படின்னு எழுதுறோம். Okay, velocity is a vector, so I'm just putting a bar. So V bar Cm is equal to, where Cm represents center of mass, so we can write, now it's the product of mass and its velocity. Unlike the previous term, it is basically mass times the distance. Here we are writing in terms of mass times its velocity, so we can represent the velocity of the center, say v1 plus m2 v2 in the mari you can express, so on until mn vn divided by sum of all the masses, which is m1 plus m2, so on up to mn. So in the mari we are generalizing. Again the same logic, instead of distance here I am representing velocity. That's the only change that we are doing. So otherwise VCM has got the formula. Velocity of center of mass of n particles can be represented using summation sigma mi vi upon sigma mi. This is the relation that we will use, and we can find out the velocity of center of mass of n particle system. Quite simple. Okay, if there is no force that is going to act, suppose your net external force acting on the system of n particles, if it is going to be 0, then what was going to happen to the velocity of center of mass? That is going to be constant. If there is no external force that is going to act, in that case it is going to remain constant. So that is one point that you guys should remember. That is a condition. Okay, this is the formula for velocity of center of mass. So with this we proceed further. We'll go to the next part. Same way நம்ம வந்து acceleration of center of mass கூட எழுதலாம். Again you modify it for acceleration. Again it's a product of mass times acceleration. So I will be writing that also. So next we are seeing acceleration of center of mass. So when I take n particle system, the acceleration of center of mass is given by ACM. Again acceleration is a vector. I'm using an arrow symbol. So ACM bar is equal to, again it's m1a1 plus m2a2, so on until mnan upon sum of all the masses. Okay, that's it. So again in summation I can represent ACM is equal to sigma mi ai upon sigma mi. So this is the formula for acceleration of center of mass of n particle systems. Okay, simple. So this is all about the center of mass for particle systems. So in general we can write down the system of mass, the center of mass for the n particle system use Bayesian relations. Same thing we are trying to modify for velocity of center of mass and acceleration of center of mass by using velocity and acceleration terms appropriately. So that is what we have done so far. Okay, so I hope it's quite understandable. Nothing is getting complicated. So you understand, you pay attention, it's quite simple. Okay, nothing is difficult. Now here you want to write down the units, yes, standard units also you can write. I think you know the units of acceleration, so that's the reason I'm not touching that part. So acceleration, the unit is meters per second square. For velocity, it is meters per second. I hope you guys are already clear with that. Okay, so that shouldn't be a problem. Fine. So that is all about it. Now we have done with the center of mass concept. So now we are moving on to the next part of center of mass. We have done with center of mass for n particle systems. Now we are moving on to the center of mass of certain rigid bodies. So before that, can anybody tell me what do you mean by a rigid body? Okay, that is the next part we are going to see. What is meant by a rigid body?
Sir, shapeless object.
Shapeless object. Abhina, rigid body, you mean to say it does not have a proper
Yes,
shape?
sir.
Okay, actually it's wrong. You're telling the other way around, opposite சொல்றீங்க. Rigid body, rigid அப்படினாலே என்ன? It is quite sturdy, right? So easily it cannot be deformed by application of force. So நம்ம அதுதான் நம்ம rigid body அப்படின்னு சொல்லுவோம். Rigid அப்படின்னா என்ன? It is quite strong and it is having some, it can withstand impact, okay, and cannot get deformed easily on impact. You call such bodies as rigid bodies. Okay, that is the definition that I was looking for. Okay, so rigid body, so basic meaning we will see for rigid body. So rigid body is one which is a solid object which can withstand deformation. Deformation அப்படின்னா என்ன? Any force, ஏதோ ஒரு force நீங்க அப்ளை பண்ணீங்க அப்படின்னா it can withstand that force. It will not break or it will not shatter. இப்போ கிளாஸ் எடுத்துக்கிட்டீங்கன்னா கிளாஸை நம்ம சுத்திலால ஒரு அடி அடிச்சோம்னா உங்களுக்கு தெரியும் கிளாஸ் என்ன ஆகும்? தூள் தூளா போயிடும். It becomes, it shatters into pieces. It is brittle அப்படின்னு சொல்லுவோம். But when you take a rigid body, for example ஒரு iron block எடுத்துக்கோங்க, சரிங்களா? When you take an iron block and you beat it with a hammer, is it going to break into pieces? Will it shatter into pieces? Not necessarily. It will not, right? Because it is quite rigid, it is quite strong, okay, and take impact. So இதே iron block வந்து நீங்க heat பண்ணி beat பண்ணீங்கன்னா அது வந்து that is different. So there what you are doing, you are supplying external energy, you are heating it, therefore you can mold it into different shapes, or you can beat it and you can thin it. That's different. But in the normal state, when you apply force, that object or that body should not change its shape, okay, easily. So which can withstand impact. When you apply any sudden force, it has to withstand the impact. Such bodies are typically termed as rigid bodies. Okay, I hope the definition, the concept of rigid body is quite clear now. Okay, so in physics we can define rigid body as a solid body. So I'll just make a note of it. Okay, so it is a solid body which can withstand deformation. Okay, so such bodies we call it as rigid body. So any solid body that can withstand deformation to an extent, you can call them as rigid body. So you have n number of examples for that. Okay, so that's all about the rigid body. Okay, so all metallic bodies, so which have higher tensile strength, they all come under the category of rigid bodies. So having understood the basic idea of rigid body, so we will proceed further. இப்போ நம்ம center of mass of certain for a certain regular objects இல்லனா ஒரு regular figures ஓட center of mass எப்படி கண்டுபிடிக்கிறது அப்படிங்கறத நம்ம பார்க்கலாம். இப்போ basic formula we have seen for system of particles. So center of mass for certain objects அப்படினா the center of the basic idea of center of mass, it's a point where the entire mass of the system is said to be concentrated at that particular point. So on the point when you're going to place and when you're going to see, the thing is going to balance. Okay, so it will totally balance at that point upon the center of mass. So it can balance. Same thing now we are going to see even for this certain objects. Okay, so next we are going to now look at the center of mass of certain rigid bodies. Okay,
என் மதிப்பு அது ஸ்கேல் ஆகும். என் மதிப்பு ஸ்கேல் ஆகும். பார்த்தீங்கன்னா
So சில rigid bodies ஓட center of mass வந்து we are going to analyze the center of mass of certain rigid bodies. First rigid body, let's start with simple figures and eventually we will go to complex figures. The first one we will look at a rectangle. Okay, so we will take a rectangle. So rectangle, we always know that rectangle has got a particular length and a breadth. Length is not equal to breadth for a rectangle. We all know that, right? Properties of rectangles, figures. So you have a length and you have a breadth, and length is not equal to breadth for a rectangle. And equal aichina, we don't call it a rectangle anymore. It becomes a square. We know that. So for rectangle எடுத்துக்கிறோம். Where does the center of mass for a rectangle? Guess. Yes. So center of mass for a rectangle is the point of concurrency of the diagonals when they bisect at that point. The point of bisect symmetry. Yeah. So you can even take the symmetry and the point of concurrency of symmetry line கூட நீங்க எடுத்துக்கலாம். Vertical line of symmetry or horizontal line of symmetry நீங்க draw பண்ணீங்க அப்படின்னா it will exactly meet at that point. அப்படி இல்லைன்னா you can also take the diagonals. For ரெண்டு diagonals நம்ம எடுத்துக்கலாம். I am marking the diagonals using dotted lines. Here there is one and here there is one more. Okay, so you can see both of them are meeting at this point. In the point வந்து நான் own வச்சுக்கிறேன். So this point O is the center of mass. Are you getting it? So this is the center of mass of a point of center of mass of a rectangle. Okay, same way நீங்க second for a square பாத்தீங்கன்னா, what about a square? Is it same as a rectangle? For a square, where is the center of mass lie? So when you take
that also intersection of two diagonals.
Yes, for square also the center of mass will lie at the intersection of the diagonals. Okay, this, so you take the diagonals. So if the diagonals are intersecting at that point, so that is a point where your center of mass is also going to lie. So this is a point of center of mass for the square as well. Okay, what about a circle, children? For a circle, where will it lie? Anybody? For a circle, where does the center of mass lie?
Origin, sir.
Origin இல்லனா சென்டர்னு சொல்லுவோமா? சர்க்கிளோட சென்டர் தானே, அதோட மையப்பகுதி, right? So circle center. So you know that circle has got a fixed radius, isn't it? Okay, so radius, it is the point of intersection of two diameters of a circle. So ஏதாவது ஒரு ரெண்டு diameter நீங்க எடுத்துக்கலாம். So the point of intersection of two diameters, what are the point of intersection of diameters called? You call it the center of the circle, right? So that is the point where the center of mass is going to lie. So this is the point. Okay, so point O, I am marking by default as point O for all the figures. Okay, so that there is uniformity. Fine. So next we will move on to the next figure. Circle பார்த்துட்டோம். What about a semicircle? Half circle. Circle la பாதி.
Okay, we will meet again in the
So semicircle.
Thank you.
You take a semicircle. I'm just drawing an approximate figure, and I'm doing a freehand drawing. Okay, this approximately looks like a semicircle. சரி, semicircle எடுத்திருக்கிறேன். Circle la பாதி எடுத்திருக்கேன். So where does the center of mass for a semicircle lie? Anybody? Yeah? No idea? So semicircle la பாத்தீங்கன்னா, what is this length called? நான் இப்போ ஒரு லைன் வரைஞ்சிருக்கேன். What is that length called?
Radius.
Very good, this is the radius. இது radius அப்படின்னா இது நம்ம சென்டர்னு வெச்சுக்கலாம் இல்லையா? This is the center, right?
Yes, sir.
இப்போ full circle எடுத்துக்கிட்டீங்கன்னா அது சென்டரா இருந்திருக்கும். பாதி சர்க்கிள்னா கூட அது சென்டர் தான். Okay, that is the center, that is a point O. இப்போ radius இருக்கு and this is a point O. Now I will mark the points. What is AB called? I am marking AB. What is length?
Diameter, sir.
Yes, it is a diameter. Now I am trying to find out what is the center of mass for this corresponding circle. So then what happens? Now, center of mass for this figure, when you're going to identify, okay, now you will see that radius at a particular distance, now at a particular distance in the sense, now total radius is r, but for semicircle, when you try to find out halfway along the radius, now that is where exactly your center of mass is going to lie. Halfway in the radius abdina ennadu. So it is at a point somewhere in between here, that is r by 2. So it is at that corresponding point. So we can also find out that corresponding distance also. So when you try to calculate that particular distance, okay, so we can say this particular distance. Now on the dotted line use panni, I will just show you. So I'm extending this line. Okay, so this distance we will call it as, say, some x, ido or x in vachikalam. Okay, so this distance x is equal to, so how do we find out exactly at that particular point? Okay, so this particular distance, so we can write this as, now the total perimeter of this corresponding circle, you know that it is going to be 2 pi r. So here it is going to be 2r upon pi. Now that is what is the length that has been found. So 2r is nothing but the total, the diameter distance. So 2r by pi, when you do, you will arrive at a distance x where you find out the center of mass. So we are using something called as lines of symmetry for this. Okay, the axis of symmetry we try to find out. So what do you mean by symmetry? Symmetry is a point where the figure can be cut into two equal parts. Okay, so you know that there is a vertical line of symmetry. Same way, you can also find out the diagonals line of symmetry for this with respect to the radius. So inga or radius neenga fold pannalam, adhe mari inga or radius length kuda neenga fold panni, and then if you fold both together, you will obtain this particular point. Okay, this point then I will mark it as center of mass, cm. So this point you will get. So that is the point where the center of mass for this particular semicircle will lie. So this is something that you will have to keep in mind. Okay, so it's found out as it's 2r upon pi, that particular distance from the origin. So like that we can find out. So this usually namakku folding method, when you fold it, you can visualize and you can identify. And this length has been found as 2r by pi from point O. So O is the center of the semicircle at the bottom, base la, and center of mass, and the distance the x, whose value is 2r by pi. So this value, please keep it in mind. Okay, so this is for a semicircle. So in the mari, you can try to find out the center of mass for various figures. Okay, parallelogram you can see. You can also try to find out for a triangle, you can find out. So in the mari, you can find out the center of mass for various figures. Next one, we will look at for triangle. For triangle, it is quite uncertain. In triangles, you have different types of triangles. We have something called as equilateral triangle, isosceles right angle triangle, scalene right angle triangle. So we have different varieties of triangles. Okay, so first we will look at equilateral triangle. So what do you mean by an equilateral triangle? Already you guys have learned.
All sides are equal, sir, and all angles between the two sides are equal.
Yeah, they're equal and they're equal to 60 degrees, right, inside. So yeah, that is an equilateral. So equilateral pathinga appadina. So when you draw the equilateral triangle wherein all sides are equal, as you rightly said, okay, so I'm approximately drawing. You assume this to be an equilateral triangle. So I'm marking the triangle as A, B, and C. Okay, now where does the center of mass for an equilateral triangle lie? So when you want to find out, so what do? Again, you draw all the symmetry, lines of symmetry, 3 lines of symmetry. So what do you call the line joining the vertex to the midpoint of the opposite side of a triangle? In maths, there is a term for it. Anybody knows? The line joining the vertex to the midpoint of the opposite side of a triangle, what is it called? Is it called an altitude or is it called a median? This comes in grade 8 or grade 9. You would have learned.
Also grade 10, sir.
Also grade 10. Okay. 3 வருஷம் படிச்சிருக்கீங்க. சொல்லுங்க. Yeah. What is it called? The line joining the vertex to the midpoint of the opposite side.
Median, sir.
Very good. It is median. So point of concurrency of three medians of an equilateral triangle will give you the center of mass of the equilateral triangle. Very important. Okay. So I am drawing the medians. So three medians I am drawing just using dotted line convention. So point of concurrency of three medians would give me the point of center of mass. So this is the point of center of mass I'm representing using O here. Okay. This is for an equilateral triangle. Same way, you can also find out for a scalene triangle, the isosceles, and you can also find out for a, scalene is different and isosceles right angle is totally different. So isosceles right angle வந்து ரெண்டு side equal இருக்கும், okay, and one side is not different, wherein in scalene all three sides are different. சரிங்களா? So that way you can typically find out. Okay, so equilateral I have shown. Same way for scalene also you can find out. So isosceles I will show, then we will later, third we will see scalene. So what do you mean by an isosceles right triangle? Isosceles la right irukku, without right angle also is possible. So isosceles right angle triangle. Okay, in this two sides are equal and one side is unequal. Okay, so we can have it like this. So two sides are equal and one side is unequal, which is your hypotenuse, like this. Okay, so this is your isosceles right triangle. I will mark it as A, B, and C. Okay, so here AB is equal to BC. These two are equal sides. So how do you find out? Now for this triangle, how do you find out what is the center of mass for this corresponding triangle? Okay, yeah. Yes, anybody? So again, point of symmetry, you will always search for a point of symmetry. The midpoint of AC you will take, okay, and point B. So all the medians again you will intersect like this. This is one median, okay, and again here also another median you draw. From this point you draw midpoint somewhere here abdina. Again you will draw a median there also. So again here also you will draw another median. Okay, and they will join at a particular point here. So they are joining at a point. So you will mark that point and that will give you the center of mass of this particular triangle. So in the body you will find out the point of concurrencies of the medians. So again you will find. So like this you join all of them, all the medians, and where all the medians are going to join, or where all the medians typically meet, so that point would be your center of mass. Okay, so this is going to hold good for the triangles. Okay, so like find out the center of mass. Yes.
சார் இந்த பாயிண்ட்டுக்கு ஒரு பேர் இருக்கும்ல சார், ஆர்த்தோ சென்டரா இல்ல சர்க்கும் சென்டரா சார்?
இதுக்கு நம்ம we call this as ortho center. Okay, ortho center. Cyclic quadrilaterals நம்ம the circum center அப்படிங்கற ஒரு term யூஸ் பண்ணுவோம். So இங்க generalized நம்ம சொல்லும்போது we will call it as ortho center. Okay, yeah, அது in maths we call it like that. சரிங்களா? இங்க நம்ம center of mass அப்படிங்கற ஒரு we will use that term only. Okay, yes, but ortho center what you said is right. Fine. So I hope now the center of mass for various figures is clear. So how you can find out? அதே மாதிரி நீங்க polygons போனீங்க அப்படின்னா, that is pentagon, regular hexagon, point of concurrency of all the diagonals would give you the center of mass for all the polygons, irrespective of how many sides the polygons have. Okay, so it's by default point of concurrency of diagonals of the polygons. So அது நீங்க ஞாபகத்துல வெச்சுக்கோங்க. So now with that concept we are moving on further. அடுத்து பாத்தீங்க அப்படின்னா we are having the concept of angular velocity. So we will see what is angular velocity. Okay, so we are seeing what is angular velocity. So the basic definition, angular velocity or symbol pathina, it is given by the letter Greek alphabet omega. So this is the symbol for angular velocity. So what is meant by angular velocity? Okay, so it is nothing but the rate of change of angular displacement with time. Okay, so I'll just give you, it is defined as the rate of change of angular displacement okay, rate of change of angular displacement, you can call it as angular velocity. So in short, omega can be written as d theta upon dt. இப்படி எழுதிக்கலாம். இல்லைனா delta theta upon delta t also you can write. So this is the formula for angular velocity. இதோட யூனிட்ஸ் பார்த்தீங்க அப்படின்னா the units is radians per second. So this is the SI unit of angular velocity. Okay, so it is radians per second. So that is the unit. Okay, and what about the dimensional formula for this? So radians theta பார்த்தீங்கன்னா இப்போ sin theta இல்லைனா cos theta if you are going to substitute, or even any value, now it is having a particular value. If you take theta, any particular value, so you know that it is going to be in degrees, and that's a finite value. But time, you know that time is belonging to the fundamental base units, and therefore when you write the dimensional formula, you will write it as m naught L naught and t to the power minus 1. Why am I putting minus 1? You can see t is in the denominator. You bring it to the numerator, the power becomes negative. So adanala t power minus 1. So this is the dimensional formula for angular velocity. Okay. So this is a basic idea, concept of angular velocity. Okay, so we have seen angular velocity. Same way, angular acceleration அப்படிங்கிற ஒரு small part கூட நம்ம பார்த்துடலாம். We will look at what is angular acceleration. Very similar. It's quite related to this. Next, we are seeing angular acceleration. Now, what is angular acceleration? Okay, angular acceleration is defined as, again, we can say the rate of change of the angular velocity. Okay, so it's the rate of change of angular velocity. So அதை வந்து நம்ம angular acceleration அப்படின்னு சொல்லலாம். It is given again by a Greek alphabet called alpha. So alpha அப்படின்னு நம்ம represent பண்ணுவோம். So alpha is equal to d omega by dt. So this is the simple expression for angular acceleration. Okay, d omega by dt, or you can also say delta omega by delta t. இப்படி கூட நம்ம இதை express பண்ணலாம். So this is the formula for angular acceleration. Okay, to change in angular velocity with time. So what about the units here? This time it will be radians per second square. Okay, because when you see acceleration, you know that acceleration or unit meters per second square. அதே ஒரு லாஜிக் தான் இங்கே நம்ம அப்ளை பண்ணுவோம். So here it is radians per second square. Okay, dimensional formula for this again would be m naught L naught, but this time t to the power minus 2 வரும். Unlike there, t power minus 1 was there. So here you will get t to the power minus 2. So this is your dimensional formula. Okay, for angular acceleration. Simple. Okay, so this is again necessary. So again we are moving. இப்போ அடுத்தது வந்து we will look at angular velocity நம்ம பார்த்தாச்சு. We have also looked at angular acceleration. So these two concepts we have seen. Now we are moving on with the equations. இப்போ kinetic equations வந்து உங்களுக்கு எல்லாருக்குமே தெரிஞ்சிருக்கும். We have done it quite long ago. So what are the three kinematic equations? Can anybody quickly summarize the three equations? Can you tell me what are the three equations, the kinematic equations? Yes. Moon equations I have taught you. So what are the three kinematic equations? Try to recollect. I know it's quite long, but still, what are the three kinematic equations? Moon equations இருக்கு. Equations of motion கூட நம்ம அதை சொல்லுவோம். We commonly refer them as
u plus at.
Okay, v is equal to u plus at. Cherry, first one. Second,
s equal to ut plus half at square.
yes. Okay, third,
v square equal to u square plus 2as.
yes. So there are three equations. V is equal to u plus at. First equation வந்து நம்ம velocity time relation அப்படின்னு சொல்லுவோம். Second equation is commonly referred as a displacement time relation. Third equation is called a velocity and displacement relation. Okay, so the third equation is independent of time. and wherein first two equations are dependent on time, they're time dependent. Okay, so these three equations are called as the equations of motion in general. Now what we are going to do, we are going to transform these equations in terms of the equations for rotational motion. இந்த equations நம்ம மாத்தி rotational motionக்கு வந்து நம்ம இதை எப்படி எழுதலாம் அப்படிங்கறத we are going to see. நம்ம அதை தான் நம்ம பார்க்க போறோம். So we will transform the kinematic equations for the rotational motion. So this is, now we are going to see kinematic equations for rotational motion. When an object is going to be in a rotational motion, then how will the first equation get transformed? That's what we are going to see. Here, instead of v, we will use the term omega, because the angular velocity is involved. Whenever an object is rotating, don't you think it is rotating with respect to an angle and there is angular displacement? Yes, of course. Therefore, we will replace velocity term, that is linear velocity v is represented using equivalent angular velocity omega. So எங்கெங்க v இருக்கோ அங்கெல்லாம் நம்ம omega போட போறோம். So you can write omega is equal to initial velocity வந்து we can write it as omega naught. So omega is equal to omega naught plus, what about angular acceleration? What was the symbol? It was alpha, right? So it is alpha into t. This is the first equation. Same way, how the second equation gets transformed? Displacement. This time, what is a displacement? When an object is moving in a circular path or it is trying to rotate, what is its displacement after time?
Theta.
We will call that displacement as, very good, theta. It's called as theta, angular displacement. So its theta is equal to, again, omega naught into t plus half alpha into t square. This is how the second equation gets modified. எங்கெங்க s இருக்கோ நம்ம அங்க theta போடுறோம். In place of u, we would represent as omega naught. In place of a, we would represent alpha. That's what I have done. Same way, the third equation gets transformed as v square. We can write it as omega square is equal to, u is omega naught. So omega naught square plus 2 alpha into theta. So like this, we can transform our kinematic equations for a linear plane or linear motion to kinematic equations for rotational motion. So we have done a transformation. So that's the reason I'm showing both here. It's a compare and contrast, so it's easy to correlate and understand. Okay, so I hope now you guys have learned how to express the kinematic equations from in linear motion, for objects in linear motion to objects in rotational motion. Okay, so this is how. Now these formulas are very important for us, especially when we solve certain set of numericals. Okay, so this is how you are supposed to do a mapping. Ida mapping அப்படினு சொல்லுவாங்க. We are trying to map the equations from one particular plane to another plane. So that is from linear to rotational as far as this concept is concerned. Okay, so now we are moving on. Let's go to the next part. So அடுத்த concept வந்து is very interesting. அதை வந்து நம்ம torque அப்படின்னு சொல்லுவோம். So யாராவது கேள்விப்பட்டிருக்கீங்களா? Have you heard about this term called torque? T-O-R-Q-U-E. Okay, there is another concept called torque. We are moving to the next concept of torque. So what is meant by this torque? Torque na என்னது? So what we try to understand by the term of torque. Anybody, could you try to contribute your ideas, your views to this?
Turning force, sir.
Yes,
Turning force, sir.
very good. Turning force, இல்ல turning effect அப்படின்னு கூட சொல்லலாம், coupling அப்படின்னு கூட சொல்லலாம். That is what is called as torque. The torque is nothing but the turning effect of force. இப்போ இந்த torque concept வந்து we try to understand in a simple term. It's not complicated. இப்போ turning force நம்ம எங்கெல்லாம் அப்ளை பண்றோம்? In our day to day life, எங்கெல்லாம் இந்த turning force வந்து நமக்கு உபயோகப்படுது?
Turning of tap, sir.
Very good.
Opening of our bottle cap, sir.
Yes, bottle caps. Correct. Very good. Same way, we are also applying turning force when you're driving a car. Steering wheel, நம்ம steer பண்ணும்போது, திருப்பும்போது. So there and all, we are going to use a turning force. Same way, turning force is also used, by people who are especially, the mechanics. Okay, mechanics, people who are in mechanics, job. especially when they are trying to open any particular object. Okay, say when they are trying to open a particular box or an object or any particular engine parts, nut இருக்கும், bolt இருக்கும். So nut bolt எல்லாம் எப்படி கழட்டுவாங்க? So how they are going to open any particular machine part, especially when there is a nut or when there is a bolt, or allen key use பண்ணும்போதோ இல்ல ஒரு நட்டையோ ஒரு போல்ட்டையோ when they are trying to open, how they are doing it? They apply a turning force. Yes or no? ஒரு wrench use பண்ணலாம், இல்லனா ஒரு spanner அப்படின்னு சொல்லிட்டு ஒரு tool இருக்கு. They will use a spanner. Have you all seen a spanner which is used to open a
Yes,
bolt,
sir.
Yes, sir.
tighten a bolt, isn't it? Yeah. இப்போ அந்த ஸ்பேனர் எல்லாம் வந்து நம்ம ஓப்பன் பண்ணும்போதோ இல்ல திறக்கும் போதோ ஒரு நட்டையோ ஒரு போல்ட்டையோ வந்து நம்ம லூசன் பண்ணும்போதோ இல்ல டைட்டன் பண்ணும்போதோ நம்ம என்ன பண்றோம்? நம்ம வந்து ஒரு டார்க், ஒரு ஃபோர்ஸ் வந்து நம்ம அப்ளை பண்றோம். அந்த ஃபோர்ஸ் வந்து we apply in such a way that the effort is very very less to do the job. நம்ம வந்து ரொம்ப சிரமப்பட தேவையில்லை. With very less effort we can easily open or we can close or we can tighten a particular bolt or particular nut. Now how is that possible? That is possible by something called as a torque, a moment of force அப்படினு சொல்லலாம். So there is a moment of force that is involved. For instance, now I will try to show it here itself diagrammatically. இப்போ நீங்க nut or bolt நீங்க பாத்தீங்கன்னா it will be like this in a hexagonal shape. Have you guys observed? Right? So it looks like this, isn't it? So say this is a hexagonal nut or it's a hexagonal bolt அப்படினு வெச்சுக்கலாம். Now for this what do? We are using a spanner. இப்போ நம்ம கையிலேயே வந்து இதை ஓப்பன் பண்ண முடியுமா? Using our fingers, is it possible for us to open a nut or a bolt? Is it
No,
possible?
sir.
No. ஏன்? ஏன்னா நம்ம கையில வந்து the length and leverage that we use is very less. Even though you're putting more effort, you will not be successful in opening a nut. Why? That is because the amount of the distance from the application of point from the axis of rotation. So axis of rotation for the nut வந்து எங்க இருக்கும்? அதோட center of massல இருக்கும். Center of mass for hexagon வந்து நான் சொல்லி கொடுத்திருக்கேன். It is a point of concurrency of diagonals. So this is the center of mass. இப்போ நம்ம force வந்து ஒரு small distanceல யூஸ் பண்ணோம் அப்படின்னா you will not be able to open it. Okay, so the moment will be very very less. இதுவே if I am going to apply force at a certain distance, say at a distance away from the axis of rotation, the axis of rotation is O, but I am applying the force at a point P, then I would be successful in opening the nut, provided the force is perpendicular to the axis of rotation at that particular point. So this is basically the concept of torque. So we will see now here. When you see this spanner, I think you guys would have seen it in the shape la irukum. It will be like this. Okay, and then you will have this particular spanner which is present. Okay, and again see it will be like this. And அதுக்கப்புறம் நம்ம இங்க வந்து force யூஸ் பண்ணுவோம். இப்போ நம்ம force இங்க யூஸ் பண்ணும்போது we will apply force either like this or we will apply force like this. ரெண்டு விதமா நம்ம force apply பண்ண முடியும். ஒன்னு வந்து clockwise rotation achieve பண்றதுக்கு நம்ம apply பண்ணலாம். இன்னொன்னு வந்து we can apply to use an anti-clockwise rotation. Clockwise rotation is used to tighten and anti-clockwise rotation is used to loosen the nut. Obviously நமக்கு வந்து தெரியும் இல்ல, tap open பண்ற அதே ஒரு மெக்கானிசம் தான் இங்கேயும். So when you're doing clockwise rotation it will tighten, same way anti-clockwise rotation it is going to loosen. Now can you see that from the point O to point P, this particular distance, okay, that is called as R. That is a distance from my axis of rotation of the nut. சரிங்களா? So that is your nothing but your axis of rotation. So we can call that as your displacement vector or your position vector. Same way your force. So what is the angle between your displacement vector or the position vector and your force? ரெண்டுத்துக்கு நடுவுல what is the angle அப்படின்னு பாத்தீங்கன்னா the angle is precisely equal to 90 degrees. So to achieve maximum torque, the angle has to be 90 degrees. Quite interesting. How do we establish that? Now torque is given by the letter tau. இது வந்து tau அப்படின்னு சொல்லுவோம், ஒரு Greek alphabet இது. It's called TAU, tau. Tau is equal to, it is a cross product of two vectors. One is your position or displacement vector R. Okay, R bar cross F bar, where F is nothing but your force vector. இப்போ cross product வந்து நம்ம resolve பண்ணோம் அப்படின்னா what do you get when you resolve a cross product? You will get r magnitude of this r, so vector r oda magnitude is r, and force vector oda magnitude வந்து f, so r into f into cos theta or sin theta.
Sin theta, sir.
Exactly, sin theta. So when is for which value of theta is sin value maximum?
90 degrees, sir.
Yes, அதனால தான் angle வந்து is 90. So நீங்க எந்த 90 தவிர வேற ஒரு small 45லயோ நீங்க 30யோ இல்ல 60 force apply பண்ணினா you will not be successful in tightening or opening. 90 perfectly, you will be able to do the work with minimal effort. Okay, so this is the concept of torque. Torque is nothing but the moment of force at a particular point from the axis of rotation. With minimal effort you can do the work, you can do the job, okay, of applying a greater force, and you will be a lesser force, and you can do the work. Okay, so that's the basic idea of torque. So that is, so tau is equal to rf sin theta, and for theta is equal to pi by 2 radians or 90 degrees. Torque is going to be maximum, so that is the maximum condition for torque. Tau max is equal to r into f. Okay, so this is the condition for torque. The general formula I have written above. Now what is the SI unit for torque? Torque oda SI unit வந்து என்னது? You have two important terms. ஒன்னு வந்து r இருக்கு. r வந்து எதை குறிக்குது? That represents length. Length is meter, and f is force. Force oda unit பாத்தீங்கன்னா it is Newton. So you combine both of
It's Newton meters,
them,
sir.
get Newton meter. So the SI unit for torque is Newton meter. What about the dimensional formula? Can anybody tell me what is the dimensional formula for torque? Okay, force oda force அதுக்கப்புறம் உங்களுக்கு அந்த டிஸ்பிளேஸ்மெண்ட்டும் இருக்கு. Okay, so first displacement எழுதலாம். So what is the dimensional formula for displacement? Only length, isn't it? So வெறும் L போட்டுக்கலாம். But force oda dimensional formula, how do you write? Force is mass into acceleration, isn't it? So you do it. What are you getting? M, mass is there. Acceleration?
LT to the power minus 2.
Yeah, L t power minus 2. So combining them, so force order dimensional formula is nothing but m L t power minus 2. That is the dimensional formula for force. Okay, so L times m L t power minus 2. You combine both of them, what do you get? You will get the dimensional formula as m L square t power minus 2. Don't you think it is same as work done on energy? Isn't it? The dimensional formula is same. Okay, so this is the dimensional formula for torque. Okay, so now I hope the concept of torque is clear to all of you, right? So this is all about the concept of torque. Okay, so this is something that you will have to keep in mind. So torque or a formula, how is it applied? What is the conditions for maximum torque? And appropriately its SI unit along with dimensional formula. So all this we have covered so far. Okay, so this is all about it. So now we are going to see the next particular part. So அடுத்தது வந்து we will look at the other parts. Next we are going to see what is the work done by a torque. Okay, so torque பார்த்தாச்சு. Next we are going to see what is the work done by a particular torque. So that is the next concept. So what is meant by work done by a torque? Okay, so that is nothing but given by the relation work done as W. நம்ம எல்லாருக்குமே தெரியும் நார்மல் ஒர்க் டன் வந்து ஃபோர்ஸ் இன்டு டிஸ்பிளேஸ்மெண்ட். பட் ஒர்க் டன் பை டார்க் அப்படின்னு சொல்லும்போது ஸோ இட் இஸ் நத்திங் பட் டார்க் இன்டு ஆங்குலர் டிஸ்பிளேஸ்மெண்ட். ஓகே, ஸோ டார்க் டைம்ஸ் ஆங்குலர் டிஸ்பிளேஸ்மெண்ட் விச் இஸ் தீட்டா. Okay, that is nothing but your work done by torque. So in simple terms you can write tau into theta. Tau theta அப்படின்னு எழுதுறோம். Okay, so this is the work done by a torque. That is the relation. Same way, we can also write what is the expression for power. What is meant by power? Power is nothing but the rate of doing work. Yeah, by definition, by general definition, power is the rate of doing work. So having that simple analogy, you can write power as the simple formula. You can write power P is equal to rate of doing work up now. You can write it as dW by dt. Okay. So again, I go and substitute for work done. Work done is tau into theta, right? So we can express that. Okay. So I'm expressing, so d by dt of, in the place of w, I'm putting tau into theta. Okay. So here now I can take torque outside because torque is typically constant. Okay. So I will keep it like that. Tau into, what is d theta by dt?
Omega, sir.
Yeah,
Angular.
yes, that is omega. So we can write power as the product of torque into angular velocity omega. So this is a relation which we have now derived. So power can be expressed as the rate of doing work, can also be expressed as a product of torque and angular velocity omega. So what will be the unit of power? Having this in mind, okay, so what would be the unit? The standard unit here, usually it is watts. There is no change, but you can see SI unit is going to be watt or watts அப்படின்னு கூட சொல்லுவாங்க. So here torque unit வந்து செப்பரேட்டா நம்ம எழுதலாம். So torque unit is Newton meter and omega, the unit is radians per second. Okay. So radians per second. Radians வந்து usually dimensional formula நீங்க எழுதும்போது you know that it is only t power minus 1 here. So for omega it is only t power minus 1. மற்ற ரெண்டு terms may 0 தான். And for torque, what was the unit? Dimensional formula m L square t power minus 2, isn't it? That was for torque. Combine both, what do you get? You get m L square t power minus 3 varada. So this is the dimensional formula for power. Okay. The dimensional formula for power is this. Okay, this is the dimensional formula. I hope it's clear. So this is how you find out what is the relation for power in terms of torque and angular velocity. Okay, and then we can also write down its SI units we know, and then writing the dimensional formula. Okay, this is all about. Sharingla. So now we'll move on to the next concept. The next concept is angular momentum. Moving on to that. Then we have angular momentum. So again, what is angular momentum? Okay, so angular momentum is for a particular particle. If you're going to look at, so we can define angular momentum of a particle about a particular axis. So we can write that as the product of linear momentum, okay, and times its distance from the axis of rotation. So angular momentum in simple terms, so it's given by the representation or denotation as L. So it's a product of the distance from the axis of rotation times the times அப்படின்னு சொல்லும்போது you have to keep in mind it is cross product. So R bar cross P bar, where R is nothing but your displacement or your position vector from the axis of rotation, and P bar is nothing but the momentum of that particular particle. Okay, so when I'm going to resolve the cross product, you know that you can write this as R into P into sine theta, where theta is the angle between your displacement vector and the momentum vector. Okay, so theta is angle between R bar and P bar. Okay, that's your theta. So therefore you can write it as Rp sine theta. When it is going to be maximum, the conditions would be same as torque. For theta 90, it's going to be maximum. 0, it would be minimum. Okay, so that's all about the angular momentum. Again, you can write down what is its unit, the SI unit for angular momentum. So திரும்பி நீங்கள் SI யூனிட் எழுதுனீங்கன்னா, ஸோ வாட் இஸ் SI யூனிட் ஃபார் திஸ்? R is nothing but meters. Momentum oda unit pathina, it is momentum is mass into velocity, right? So kilograms meters per second times meter. So what do you get? You get kilograms meter square per second. So that is what you get, the SI unit. Same way, dimensional formula. What will be its dimensional formula for this? Kilograms na mass, so m, meters square irukku, so L square. Second is the denominator, you bring it up, so T power minus 1. Quite understandable. Okay, so this is the dimensional formula. Okay, so that is how you write the dimensional formula for angular momentum. Simple. So this is the concept of angular momentum. Okay, simple. So now after this, we will see what are the relations between different physical quantities that we have learnt in this chapter. So what is the relation between torque and angular momentum? Can we establish a relationship? So we are going to see. Okay, so next we will see what is the relationships. So relation between torque tau and angular momentum L. So there is a relation, very important. So you can write torque as change in rate of change of angular momentum. You can write torque as dl by dt. Okay, so this is again one relation that you will have to keep in mind. So you can express torque as the rate of change of angular momentum. Okay, so this is one important aspect. So this is one relation that is important for us. Okay, so like this you can, this is one relation that you need to keep in mind. Again, when you see the units would remain same. Ena torque oda unit vanda adhe da, newton meter da, there is no change in that. Same way for angular momentum also. Okay, so that is holding good. So this is about it. So this is a relation between two quantities. Now we are moving on to the next part, so which is called as the radius of gyration. Okay, so we'll see that also. Before that, we will see moment of inertia, so that is required. So adukapra we will see the radius of gyration. So moment of inertia pakla is an important concept. Okay, so moment of inertia generally given by the letter I. Okay, so what do you mean by moment of inertia? Moment of inertia na ennadu? What do you try to understand by the term moment of inertia? Okay, so when you say moment of inertia, now inertia அப்படிங்கும்போது inertia has got a different meaning. Okay, so what do you mean by just inertia? Newton's first law அப்படின்னு சொல்றோம். Newton's first law வந்து law of inertia கூட சொல்றோம். ஏன் சொல்றோம்? What do you try to understand by the term inertia? Okay, what comes to our mind when we think of the term inertia? Yes,
The body resists the external force, sir.
correct. The resistance of a body to any change, in the state of motion. அதுதான் நம்ம இனர்ஷியான்னு சொல்றோம். The tendency of an object to resist the change in its state of motion, you call that as inertia. Very good. So Newton's first law explains that concept only. That's the reason we say Newton's first law as the law of inertia, right? An object continues to be in the state of rest or of uniform motion until it is acted upon by an external unbalanced force, right? So that is called the law of inertia. Now examples for inertia வந்து நம்ம day to day lifeல வந்து real lifeல we keep experiencing inertia multiple times, especially when you're traveling from home to office or home to school or to your college. You experience inertia some or the other way. Okay, so say you're traveling by bus. Okay, so bus comes to the bus stop and you're boarding the bus. Now what happens as soon as when you board the bus? Do you experience a jerk when suddenly the bus accelerates?
Yes, sir.
Why do you experience that jerk? What is that called?
The backward push, sir.
Yes. So whenever a bus at rest, when it accelerates suddenly, passengers are jerked. Do we jerk forward or do we jerk backward?
Backward, sir.
Yes. So we jerk backward. Why? That is because the bus is in motion, but the passengers in the bus remain to be at rest for some time. Right? especially there, especially our upper part. Our upper part of the body is at rest, but lower part sets to be in motion along with the bus when it suddenly accelerates. Therefore, that is called as inertia of rest. So when an object at rest suddenly it accelerates, so with respect to the frame of reference of the bus, our lower part of the body is in motion, but the upper part tends to remain in rest. So therefore, we are suddenly jerked backward. Okay. Same thing when a moving bus stops suddenly, when the driver applies brakes and he stops the bus, what happens to the passengers in the bus?
We move forward, sir.
Yeah, the passengers in the bus are jerked forward. That is because of inertia of motion. Okay, the bus comes to rest immediately, no doubt, but the passengers tend to be in motion. Okay, the lower part of the passengers. Okay, so therefore the passengers are jerked forwards. So this is something that you will have to keep in mind. That is the idea of concept of inertia. Inertia nave adudha. So the jerking of passengers either forward or backward or any particular object, okay, when suddenly it is being stopped or when suddenly there is an acceleration, there is a tendency to resist the change. That tendency you call it as inertia. So that is the concept of inertia. Very, very simple. Okay, so inertia, when the based on inertia there are so many DIY also, do it yourself activities or experiments are there. நீங்க வந்து ஒரு you can take a glass, you can place a card over the glass, you can there are cards and playing cards. You can take one card from the deck of cards, place it over the glass. You can keep a small coin over it. It can be a 1 rupee or a 5 rupee coin. Preferably you can take 5 rupee. Okay, that's got a greater mass. So you can take the 5 rupee coin, you can place it over the center of the card. The card can be placed over the glass. Now what happens when you flip the card using your fingers? What happens? Does the coin fly away with the card?
No, sir, it falls down, sir.
Yes, it will fall inside the glass. Why? Because of inertia. The coin is in the state of rest, but the card is suddenly in motion. When you're flipping using your fingers, the card suddenly accelerates, but the coin is in the state of rest and hence it will fall inside the glass. That's a simple activity to demonstrate the concept of inertia. Okay, so like this we have so many interesting experiments which you can try for yourself and you can experience the concept of inertia. You can try to understand by putting yourself in that situation. Okay, so that is what is inertia. Now here we are going to take that concept of inertia to the next level and we try to understand what is moment of inertia. Okay, so moment of inertia, when I say, it is again very simple. It is the property where an object which is in rotational motion, that is going to resist the change, okay, with respect to the axis of rotation. Then I call it as moment of inertia. So when there is a particle which is experiencing a circular motion with respect to a common fixed point of motion, then I call that as moment of inertia. There is a simple formula for this. Moment of inertia is given by the relation I is equal to sigma mi square. Now what is mi? Mi is nothing but the mass of the system of particles. If I'm going to take a particular rigid body and if that body is going to be in rotational motion at certain parts, then those areas, the masses, I can represent as mi. It can be m1, m2, m3, so on up to mn if you're going to cover up the entire body. And what is r? R is nothing but the distance from the axis of rotation. Okay, very simple. So this is the formula for moment of inertia. If I'm going to expand this, what will I get? I will get m1 r1 plus m2 r2. Okay, square. Don't forget to put the square. One second. Let me just come back. I just pressed one key. Yeah. So m1 r1 square, m2 r2 square, so on until mn Rn square. This is a general representation, general formula for moment of inertia. People, moment of inertia is there for different objects. Okay, different objects have different values for moment of inertia. Okay, so there are set of formulas that it's better that you learn them at once because deriving all of them would consume a lot of time. So I will give you all the formulas. So you need to go through those formulas, for the next session. So we can start off with all numericals. So we are coming to the end of the concepts. So I will give you the moment of inertia for various objects. Okay. So first we will look at for a thin rod. Okay. So let me just give a suitable heading for this. Moment of inertia for various objects. Let me just put it. Then I'll give you. Oh my god, I've taken a thick pen. Yeah, so we will see moment of inertia for various objects. Okay, so நம்ம எல்லா ஆப்ஜெக்ட்ஸுமே பார்க்கலாம். ஃபர்ஸ்ட் வந்து we will look at for a thin rod. Okay, or just a rod ன்னு கூட நீங்க சொல்லலாம். Okay, I'm just taking a thin rod. So when I take a thin rod, how does that rod look? It is very thin. Okay, it will be like this. Okay, the length of this rod we will take it as L, capital L வச்சுக்கலாம். That is the length of this rod. Now, what is the moment of inertia for a thin rod if its axis of rotation is at the center? Axis of rotation வந்து நான் சென்டர்ல வச்சுக்கிட்டேன் அப்படின்னா exactly at the center means at a distance of L by 2 from the end. சரிங்களா? That is the center of that rod. So if the axis, if this rod is going to rotate with respect to the axis at its center, then moment of inertia is given by the formula I is equal to ml square, okay, upon 12. This is the formula for moment of inertia for a thin rod which is rotating about its axis exactly at its center. Okay, this is the formula. Same way, if I'm now going to change the axis of rotation for the same thin rod, okay, so say if I'm going to place it at one of the ends, or end if I'm going to place, and if the rod is going to rotate with an angular velocity of omega, in that case, okay, the length is not changed, same length L da. Okay, so in that case, what is going to be the moment of inertia? It will change. It's not going to be the same. Then moment of inertia changes as ml square upon 3. So this is the formula when it is having its axis at one of its ends. Okay, this is for a thin rod. There are two possible formulas. One is for at the center, moment of inertia when it is exactly at the center, the axis. The other one is at the end, either of the ends. Okay, it can be the left side or the right side. That is your choice. Okay, so this is the moment of inertia formulas for a thin rod, provided the axis of rotation is at the center, and for the second case, the axis of rotation is at one of the ends. Now going to the second object. The second object is a circular ring. So we can take a circular ring. Circular ring, now you can see real life examples. Your donuts, okay, our vada, our medu vada. Your donut can be an example. Bangles can be examples for rings. Okay, so like this you can imagine real life examples, right? So for circular ring, so you draw the ring, okay, like this. You have a ring like this. Okay, a very small thickness you just show, and you just shade it like this. Okay, this is a ring. You can shade it like this. So this is a circular ring, and it's having a center O, and obviously this is going to be its radius. Okay, this length. In that case, so again here you have different combinations. First, if your axis of rotation is exactly at the center of the ring, okay, passing through the center, if it's going to pass, in that case, okay, if it's exactly passing through the center of the ring and it's perpendicular to the plane of the ring, that is also very important. It makes an angle of 90 with the plane of the ring. In that case, the moment of inertia I is given by the relation mr square. Okay, if the axis is going to pass exactly through the center of the ring and the ring is going to rotate with respect to the axis, then it is mr square. Same thing. Now if I'm going to change, again I will show the same ring. Okay, you show the ring, and again I will shade it. This time I am not placing it in the center, rather I'm going to place the axis of rotation at a diameter. Diametrically I'm going to pass it. Okay, It is along the diameter. So if the ring is going to rotate along the diameter with an angular velocity of omega, in that case, the moment of inertia is now going to change as I is equal to mr square divided by 2 when it is about the diameter. Okay, so this is how it changes. So like this, for various figures, we have the particular values for moment of inertia. Okay, this is one more possibility. The last possibility is for the ring when the axis of rotation is, say, at the end of the ring, or you can say it is tangential to the ring. So when I take it tangential to the ring, so say I am taking the axis, I am placing it as a tangent. So you know what is a tangent, right? It's a line passing, just touches the ring like this. Okay, so I will draw just a tangent here, a random tangent I am drawing. It should actually touch. So you just show it touching like this. Yeah, it now came. So this is a tangent. So if the axis of rotation is at the tangent, then the moment of inertia is going to be different. So then it is given by I is equal to mr 3 mr square upon 2. This is the formula when it is passing at the tangent. This is for tangent. The second one was for diameter. Okay, when the axis is passing, and the first one is exactly for the at the center. So like this, we have 3 different cases for a circular ring. Okay, so like this, we have the cases that you will have to be knowing. So we have done with the ring. அதே மாதிரி நமக்கு இன்னும் நிறைய shapes இருக்கு. So அது வந்து it will take time. The next class I will show you all the other shapes, but I'll give you the formulas. Better you learn the formulas and keep. You just go through them. Okay, I'll just post it in the group. Fine. So circular disc இருக்கு, அதுக்கப்புறம் solid cylinder இருக்கு. Then we have hollow cylinder, solid sphere we have, and hollow sphere we have. So these are all the other shapes, 3-dimensional shapes which we are left with. Okay, so that we will see. So with that, we'll come to the end of this chapter. So just a few more formulas left, for which I'll be sending the notes. Okay, you can just go through it, the formulas. Fine. Yeah, so we'll wind up for today. So I hope you guys have understood the chapter system of particles and rotational motion, right? So then we will start off with numericals. So I have now brushed up and revised, touched all the concepts, the important formulas and definitions. Yeah, so we'll meet up again. So tomorrow we have another class. Tomorrow we will see, and we can do the questions also. Fine, so this will be over. Okay, yeah, thank you children. So I hope you've understood. So I'll just even post this notes also, you can go through it as a reference. Okay, so any doubts you have, you can ask. Okay, in case you have any doubts in today's concepts, anywhere you're stuck, you have marked it and kept, you can ask.
சார் இந்த ரிங்ல வந்து ஒரு ரேடியஸ் தான் இருக்குமா சார்?
ரிங்ல வந்து ஆமா ஒரு ஃபிக்ஸ்ட். ஆக்சுவலி பாத்தீங்கன்னா திக்னஸ் கன்சிடர் பண்ணீங்கன்னா it will be having a particular thickness. Okay, but நம்ம வந்து ஜெனரலா தான் அந்த ரேடியஸ் எடுத்துக்கிறோம், ஆர்னு எடுத்துக்கிறோம். ஏன்னா திக்னஸ் வந்து நம்ம நெக்லிஜிபிள் வச்சுப்போம். ஸோ அதனால we just take it as radius as r, ஜெனரலைஸ் பண்ணிக்குவோம், அவ்வளவுதான். R1 R2 அப்படிங்கிற கான்செப்ட் இங்க கிடையாது.
ஓகே,
யா,
thank you sir.
yeah, welcome. Okay children, anybody else is having any doubts or you have any queries, you can ask. Feel free to ask. Okay, don't be shy, we are here to help you out. Any queries also you can put down also in the group. You have made a group also, you can post it there as well. Instead of posting, it's better to ask and get it clarified. That is what I would suggest. Yeah, okay, I think it's clear.
Okay, thank you, Manish.
Okay, so we'll wind up, no? Okay, well.